Hello all, I am Shatabdi Acharya from Vedang Institute of Technology. So we were continuing our series of organic compounds. In the previous video, we have learnt about the nomenclature of alkanes, right? So before moving further, we will deal with some questions. So the first question we have here is C2H4. So if you ever come across these kind of questions, you have to first see the general formula. I have given you the general formula for alkanes as CnH2n plus 2. For alkenes, it was CnH2n, and for alkynes, it was CnH2n minus 2. Right? So, taking these formula as reference, we will see to which category these particular examples belong. So, if I take up the first example, it is C2H4. That means it clearly shows it belongs to the category of CnH2n. That means it's an alkene, right? And again, I have also said if I'm having carbon number 1, the word root will be meth. If I'm taking carbon number 2, it is eth. If 3, it is prop. For 4, it was but, right? And for 5th, it was pent. 6th, hex. 7, hept. 8, oct. And 10, dec. Right? I hope you have seen the previous video and you know what these word roots and how are they derived and what these word roots basically stand for, right? So, in the first example, we have C2H4 and we already know that it belongs to the category of alkene. Now, how to name this? We don't have to write the entire expanded structure here. We can only see by seeing the general formula and the number of carbon atoms, we can come to its conclusion of its name, right? So, for C2H4, the number of carbon atoms are 2. So, the word root will be eth. So, let me write eth. Now, after that, we had to write the suffix, and the suffix was determined by the category or to which homologous series that particular element is belonging. So, if I am taking alkene, then the prefix I was supposed to write was ene. For alkane, it was ane, and for alkyne, it was yne, right? So, if I am seeing this belongs to the general category of alkene, and I already got the word root as eth. So, the word will be ethene. Got it? The second, if I move on, then it is C3H8. So, if I see, it belongs to the category of C3H3 into 2 plus 2. That means CnH2n plus 2. Then clearly it falls into the group of alkanes. So, the word root for C3 carbon atom is prop. And as it falls under the category of alkane, so the suffix will be ane. So, it is propane. Okay. So, C3H8 stands for propane. Now, if I see C9H18, then obviously if you expand it, it will be a big compound, but don't be afraid, we can name it very easily. So, if we see, it falls into the category of CnH2n, right? C9H18. So, CnH2n. That means it is coming under the category of alkene. And as it is having 9 carbon atoms, so the word root for that is, and it has a suffix of ene. Right? It was simple, isn't it? So, the next category if we move on to, or the next example if we see C7H12. So, if I try to reduce its general formula, it will be CnH2n minus 2. That means it falls under the category of alkynes. Got it? And how many carbon atoms are there? 7 carbon atoms. For 7 carbon atoms, the word root was hept. The word root for 7 carbon atom was hept. And as it is falling under the category of alkynes, therefore the suffix which comes or which follows it is yne, heptine. Okay. Now if I see the last example, C10H22. So if I try to write CnH2n plus 2, so it falls under our alkane, right? And how many carbon atoms are there? 10 carbon atoms. For 10 carbon atoms, the word root was DEC. DEC. And as it is falling under alkanes, so the suffix that follows will be ANE, that is decane. Right. So I guess after solving these examples, you might be clear upon nomenclature of alkanes, alkenes and alkynes. Now, whatever we have dealt with till now was about straight chains. If carbon were connected end to end in a straight manner, okay, in a straight line fashion, there was no branching. But what if branches follows, or what if a carbon atom is branched? How will it be named? Then the rules are pretty simple, like they mostly follow the rules of alkanes but with a bit of deviation. So first of all, before naming or before moving on to the exact nomenclature of a branch chain, let us see some certain rules how we'll be naming the branch chains. Okay. So here these are certain set of rules which we have to follow for naming branch chain. And before moving on, let me just clear you about one part which we have covered in the previous video, that if I'm taking an alkane and I'm removing a hydrogen atom from an alkane, then I'm getting a alkyl group. Okay, this you must keep in mind for naming branch chain. This is the key thing you have to remember for naming the branch chain hydrocarbons. Okay, alkane minus hydrogen gives you a alkyl group, but other rules like the word root and the suffix and all that remains the same. Okay. So first of all, we have to select. Now for now, let us just see the rules. When we'll be dealing with the examples in the upcoming lectures in this video only, then you'll be clear about how we exactly name or how we exactly do the nomenclature for branch chain hydrocarbons. And remember, whenever we are doing the nomenclature for branch chain hydrocarbons or anything, any organic compound, those are basically the IUPAC nomenclature, International Union of Pure and Applied Chemistry. That is a body which determines or which gives us a set of rules following which we can deduce the name of any given organic compound, and that remains same throughout. Like wherever you go, you will find that IUPAC nomenclature is the standard nomenclature, okay, that is followed by places everywhere. So if I see the branch chain hydrocarbons, the first thing I have to do is I have to select the longest chain. Now what does longest chain means? Okay, let's deal with that. Suppose I'm saying initially for alkanes, I'm just writing the carbon skeleton, and if nothing is mentioned in the carbon, that means hydrogen is there. Carbon, hydrogen is always, that is an inevitable factor for a carbon chain to exist. If a carbon chain is there and no suffix or no other functional groups are attached, then carbon, hydrogen is inevitably present there. Okay. So if I'm seeing this carbon chain, it is having how many carbon atoms? 1, 2, 3, 4, 5 carbon atoms. And suppose, for example, carbon we know has a property called catenation. That means it can form the it has the self-linking ability. It can form n number of bonds with itself. It can go on, right? So if I'm saying I'll put a carbon here, I'll put a carbon here, again a carbon here, I can do that, right? Because of that catenation or self-linking property of carbon. So if I see this, then if this is the main chain, these will be the branches. Okay, these will be the outlets deriving from that main chain. So these are called branch carbon atoms. Okay, so for that, first of all, what I have to do, I have to select the longest chain. Now the chain can be like this. It can be a straight chain. Okay, if I want the chain, I can write as like this also. This can become a chain for me. Okay, because I already have the flexibility to like turn and twist and turn the carbon chain. Okay, I can take this as my longest chain. Otherwise, if I can like if I want, we will have to see which will be the longest chain, but I'm saying we have the flexibility to choose anything. You cannot consider that this is only in a straight line fashion, so this will be the longest chain. No, you can take this. If it is having a more number of carbon atoms, then this can also become the longest chain. Okay. If I want, I can take this also as my chain. These are certain possibilities, right? I'm just showing you what are the possibilities by which you can consider a chain. So I can take this also. If I want, I can take this as my longest chain also. Now, after getting so many possibilities of chain, I will have to choose which one will be the longest chain. Now, for that, I have to count the number of carbon atoms. The chain where I'll be encountering more number of carbon atoms, that will be my longest chain. So, if I'm seeing this blue one, first chain which I have chosen, if I start numbering those carbon atoms, then this will be 1, 2, 3, 4, 5. Okay, on my way, I'm encountering 5 carbon atoms. If I'm going from this chain, the red colored one, that will be 1, 2, 3, 4, 5. Okay, here also I'm getting 5 possibilities. Now, if I go there, I'll get 1, 2, 3, 4, 5. Okay, here also I'm getting 5 possibilities. Now, if I see this chain, this will be 1, 2, 3, 4. Okay, here I'm getting lesser number of carbon atoms in the chain. So, definitely this will be discarded. And in the other 3 possibilities, I had 5 carbon atoms in each chain, right? So, now as there are similar carbon atoms in all the 3 chains, I can choose any one chain as my longest chain. And I can pick any one containing 5 carbon atoms that I can do consider my longest chain. After considering my longest chain, the other carbon atoms attached to it will become its branches. For example, if I'm saying this, I'm choosing this chain as my longest chain, then this carbon atom and this carbon atom will become my branch. Okay, these will go to the branch chain for side. Okay. So, the carbons outside the chains are alkyl groups because, see, for this carbon atom, had this bond been non-existent, then it would be having 4 carbon atoms, that is alkane, methane. After losing one hydrogen atom only, it has formed a bond with this carbon atom. So, alkane minus hydrogen is alkyl. I have written here. So, whichever group you are seeing, they have been formed after the removal of, or they are coming into the branched section after the removal of a hydrogen atom, right? So, it was initially an alkane, it has lost one of its hydrogen atom, and then it is falling under the category of alkyl. So, whatever branches you are seeing, those are alkyl groups. And alkyl groups, the naming of the alkyl groups will be decided upon the number of carbon atoms present in the group. Okay, so if I'm seeing this as my longest chain, this main chain as my longest chain, then I got these 3 as my branches, right? And these will be alkyl groups. Here, 1 carbon atoms are there, and for 1 carbon atom, my word root was meth. Remember? So, meth, and as it is an alkyl group, so the name will be methyl. Okay, now if I'm seeing, if suppose there are 2 carbon atoms, the name will be ethyl. If 3, then it is propyl. Right. Next is give number to the chain in such a way that alkyl groups receive smallest number. Okay, if you remember students, in the previous video I have talked about something called lowest locant rule, right? Lowest locant rule. That means if I'm seeing this, I'm considering this as my branch, or this is as my given compound which I have to name, then I got one main chain, I got branches. Now, suppose I'm considering this as my main chain, then I will have to number the carbon atoms 1 to 5. Okay, there are 5 carbon atoms. I will have to go on numbering the carbon atoms 1 to 5. Suppose I'm seeing, I'm numbering it first this way. Okay, 1, 2, 3, 4, 5. Okay, but I have the possibility that I can number them from the opposite side too. That is, from this side, it will be 1, 2, 3, 4, 5. Okay. Numbering either side will not affect the carbon chain, but the number will affect the position in where the branched carbon atom is present. And I have to keep in mind, my rule says that position, or the position in which branching has started, should get the minimum number. Okay, so if I'm seeing I'm going from this side, then my branching starts at second position. Let me write second, then third, then fourth position. Now if I'm coming from this side, I'm getting a branching starting at 2, 3 and 4 as well. 2, 3 and 4. Okay, so here we are getting the same set of locants. So here we won't find any deviation. But assume, for example, there is a carbon chain where the branching is at 2 and 3 if I'm going from one side, and suppose 3 and 4 I'm going from the other side. Right, if this happens, then you have to choose the lowest set of numbers in the bracket. Okay, which carbon atom is getting the lowest position? Because we have to, according to rule, we have to prioritize the branch getting the lowest locant. Okay, so in that case, I would have chosen the 2-3 pair, and I would have started numbering the carbon atoms from that side where the locants are getting minimum number. So don't worry if you're confused here. In the next section, we are having a lot of interesting questions to practice based on this branch chain. And after practicing question, you'll be cleared, I guess. Okay, so the last is write the name of the alkyl group before the name of the main chain. Now, what does this mean? So, while naming the alkanes, what we did, we simply had to count the number of carbon atoms. Suppose there were 5 carbon atoms, and as it is belonging to the category of alkane, we have to just put a suffix ane, that is pentane, and we got our alkane before us, right? But here what we have to do, here we are having an extra part, the branched part. So, before the word root and suffix and all, those remain the same. They belong to a particular section. But before that, I have to write the name of the branching also. Suppose, now let me take a fresh example before you. I am saying I have a carbon chain which is like this. Okay. Now, if I first my rule says I will have to find the longest carbon chain. So, if I am going from this side, if I am considering this as my main chain, here I am getting 1, 2, 3, 4, 5 carbon atoms. If I am going from this side also, I am getting 1, 2, 3, 4, 5. Okay, in both the sides I am getting 5 chain, 5 carbon atoms in my chain. So, any chain can be considered as my primary chain. Now, if I consider, for example, to avoid or to create confusion, let me choose this one. Okay, I am choosing this chain as my longest chain. Now, this goes to the branching. Now, the next thing what I have to do is, I'll have to number the carbon atoms. Now for numbering, I can go from this side or this way also. So, let me do it both ways for you. I'm going first this way. This carbon 1, 2, 3, 4, 5, like this. If I'm coming from the opposite way, it will be 1, 2, 3, 4, 5. Okay, but now what I have to see, my carbon or the branched carbon should get the minimum number. So, if I'm going this way, my branching starting at second position. But if I'm coming from the other side, the other way around, my branching starts at the fourth position. Okay, I have two options, second and fourth. Obviously, I'll have to choose the second one because as per my rules, I have to go with the minimum number to the branch. So, I'm choosing my second carbon as my, or this way of naming, where my branching is getting the minimum number. My branch is getting the minimum number. Now done, I'm done with giving the number and all. Now I'll move on to the naming. So for naming, first what I have to do is, I will put the primary chain first. The primary chain is my 5 carbon atom chain, and it is all belonging to the category of alkane because all are singly bonded, no double bonds are present here. So my word root will be pent, and as there are all singly bonded carbons, so that will be pentane. Now, okay, done. This chain is named, but I'm having an extra branch associated with it. So what I'll have to do? I'll have to put the, or I'll have to start naming the branch also, but where will the branch be placed? Before the name of the actual or the primary chain. Okay, before the primary chain, I will have to name the branch. Okay. So for my branching, I have how many carbon atoms in my branch? A single carbon atom. So first I have to see at what position my carbon atom is there. My carbon is at second position. So I will write 2, then the name of the branch. How many carbon atoms? 1 carbon atom. And for 1, my word root was meth. And as it is an alkyl group, it has been formed by the removal of a hydrogen atom from methane. Therefore, that name goes to be 2-methyl pentane. Okay, 2-methyl pentane is my IUPAC name of the, had this compound be given to me for naming, then its name would be coming out to be 2-methyl pentane. Okay, I hope you're clear with this rules or nomenclature for branch chain carbons. Now let us see certain examples. After solving these examples, I'm pretty sure you'll be clear upon all the rules. Okay. So for the first one, it's the easy one. We'll start from the easy and we'll gradually increase our level. Okay. So if I'm seeing the first, let me change the color of the pen so that you don't get confused. Okay, in the first one, I'm seeing how many carbon atoms? 4 carbon atoms are there, but there is branching. So first thing what I have to do is I have to select my primary chain. Now, if I see here 1, 2, 3. So on my way of naming like this, I'm encountering 3 carbon atoms. If I see the other way, like from here, if I'm starting the naming, it will be 1, 2, 3. So here also I'm getting 3 carbon atoms. If I move from this side, I'll get 1, 2, 3. So whatever I do, whatever all the permutation combinations I have applied, but still I'm getting 3 carbon atoms on my way. So I have to like make peace with the fact that this primary chain of this particular compound will have 3 carbon atoms. Got it? So, okay, I got my primary chain. Let me choose the straight one as my primary chain. CH3, okay. So, I'm choosing this as my primary chain. Now, I can choose or I can do the numbering from this way or from that way, from left to right or right to left, whatever it is. But any which ways I do, I'll be getting my branching at the second position. So, I can do it both ways. Let me just keep it like this only. So, if I'm doing this, I'm getting my branch at the second position. Okay. And now I have encountered 3 carbon atoms in my primary chain. So, if I have to name the primary chain, the word root will be prop, because 3 carbon atoms are present. And as all are alkanes, all are singly bonded, so the name will be propane. Now, time for the branching. Now, my branching is at second position and the branch is methyl group. 1 carbon atom is present. So, the name comes out to be 2-methyl propane. Okay. Following all the rules, we reach out to the conclusion that this particular organic compound has a IUPAC name 2-methyl propane. Now, if I see the second example, okay, it kind of seems a bigger one like than the previous one, but following the rules, it will be all easy. Okay, so if I start naming my carbon chain, now what I have to do? Let me choose this one. 1, 2, 3, 4, 5, 6. Now I can go this way also. It will be 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5. Sorry, 5 carbon atoms this way. If I go other way, 1, 2, 3, 4. 4 carbon atoms. So here I have the possibility of choosing among the 3. I am having in 1 carbon atom, or in one chain I am getting 6 carbon atom, in the other chain I am getting 5 carbon atom, and the other chain I am getting 4 carbon atom. So the wisest decision will be to go with the longest chain, which is the 6 carbon atom path. So the straight chain, this one. Now I have the option of naming it from left to right and right to left, or numbering it from left to right or right to left. If I'm going from this way, I'm getting my branching at the third position. Now, if I'll be coming from the other side, it will be 1, 2, 3, 4, 5, 6. So here I'm getting my branch at the fourth position. Obviously, I'll have to give it the minimum number. So I will go with this chain, the third carbon atom one. And for this primary chain, I'm having 6 carbon atoms on its way. So the word root for this will be hex. And all are singly bonded. So the name will be hexane. It's for the primary chain. Now I will also have to name the branching. Now my branching is at third position. So I will write 3-methyl hexane. Now following the IUPAC nomenclature or the rules for IUPAC nomenclature, I came to the conclusion that the name of this organic compound comes out to be 3-methyl hexane. Okay. Now if I see the third example, we have this CH3, CH2, CH, CH2, CH3, and there is a branching of CH2, CH3. Okay, so if I start numbering the organic compound, then 1, 2, 3, 4, 5. If I'm following this way, I'm getting 5 carbon atoms on my way. If I'll go from the other side, if I can choose this as the chain also, then here also I'll be getting 1, 2, 3, 4, 5. So here also I'm getting 5 carbon atoms, and if I'm going the other way, I'll be getting 1, 2, 3, 4 and 5. So any which ways I'll be going, I'll be getting 5 carbon atoms on my way. So let me choose the simplest one, the primary chain like this. I'll be choosing this as my primary chain. So if I number this, if I'm moving from this side, then I'm getting my branching at the third position. If I'll be moving at the opposite side also, probably I'll be getting my branching at the third position. Let's see, 1, 2, 3, 4, 5. So I'm getting my branching at the third position, and in my primary chain, I'm having 5 carbon atoms, right? So the word root that follows for 5 carbon atom is pent, and all the carbon atoms are singly bonded, so the word will be pentane. Now for the branching, what I will see, I have my branching at third position, and now in this case there is a branching of 2 carbon atoms, right? CH2, CH3. So as there are 2 carbon atoms, the word root for 2 carbon atom is eth. And how it is formed? If there is an alkane called ethane, CH3, CH3, I will remove one hydrogen from any atom, any carbon atom, that becomes CH2, and I will bond it to another carbon, then I'm getting this. So from ethane, as I'm deriving this alkyl group, so its name will be ethyl, and it is in the position of 3 carbon, third carbon atom. So the name comes out to be 3-ethyl pentane. Okay. Now if I'll see the fourth example, if I'm considering my primary chain, 1, 2, 3, 4 carbon atoms this way. If I'll be going from this side, it will be 1, 2, 3, 4. This way also I'll be getting 4 carbon atoms. Okay. Any which ways I'll go, I'll be getting 4 carbon atoms in my primary chain. Now the first part is done. The second part, what I have to do? I have to do the numbering in such a way that my branching is getting the minimum number. My branch carbons are getting the minimum number. So if I'm going this way, I'll be getting my branching at the third carbon atom. But if I'm moving from the opposite side, then I'm getting my branching at the second position. So for me, the wisest thing to do as per IUPAC is giving the minimum number to the branched carbon. That means I'll go by the second carbon branching. Okay. So here I'm having 4 carbon atoms. The word root that follows here is but. And as there are all singly bonded carbon atoms, so it will be butane. Now for the branch, I'm having my branching at the second position, and here I'm seeing 2 branches. Okay, one is of the methyl group and the other is also of the methyl group. So will that 2 methyl group become the ethyl group? Obviously no. There are 2 separate carbon atoms. Ethyl group is formed only when carbon and carbon are connected end to end. Both the carbon atoms are connected together, but these carbon, this carbon and this carbon is not connected to each other, rather they are connected to this center carbon, right? So obviously they won't become the ethyl group. In this case, what I have to do, it is branching is the second position. I'm getting, I'm having 2 branches at the second position. So 2, 2, and both are of methyl group. So that is 2, 2 dimethyl butane. Had there been 3, it will be tri, tetra, penta, like this. Okay. So here I'm having 2 carbon atoms, that's why 2, 2 dimethyl butane. This name signifies I have a branching of 2 methyl group and both are in the same position, that is the second position of the main chain butane. Okay, so I hope you are clear with the nomenclature. In the next slide, we will go the opposite way. Like we were having the structure, and from that structure we were deriving the names of the compound. But here what we'll be doing, we are having names before us. From the names we will have to derive the structure of the compound. So for that, first thing you have to see, you have to follow the order, similar exact order what we were following for the nomenclature of the structure. So here what we have to do, we have to see the word root first. The last one will be the main word or the name of the main chain. So here my name is pentane, right? So that means there is 5 carbon atoms. So let me draw my 5 carbon atoms. Okay, done. 5 carbon atoms are there. Now you have to see there is a branching at the third position as well as second position. So here I am the boss. I have the name and I will just have to assign the branches of this carbon atom. So there is no need to follow the rule as to which side you have to go. You can put the names according to your wish. Suppose I'm taking this as my primary chain and I will be naming from, I'll be moving from right to left. So I will simply assign my ethyl and methyl group in the second and third position. So this second, I will be assigning a methyl group, that is a CH3 group. And in the third, I will be assigning a ethyl group, that is CH2CH3 group. Okay, now the last thing that remains for me is filling up the hydrogen. Now how I will fill up the hydrogen? See, for that I have to remember carbon only forms 4 bonds. So you have to see in each particular carbon atom 4 bonds has to be satisfied. So if I see the first carbon atom, it is only forming a single bond with the other carbon atoms. It has the scope of 3 other bonds left. So for that I will fill 3 hydrogen atoms, or I will assign 3 hydrogen atom to this carbon atom so that it satisfies its tetravalency. Now if I see the second carbon atom, we are already 3 bonds down, right? So it's left with only a single bond. So that single bond will be satisfied with a hydrogen atom. If I move on to the next carbon, it is also having the similar case of the previous carbon atom. Here also 3 bonds, we are 3 bonds down. Now it has to form only a single bond with hydrogen. So I gave that hydrogen to this carbon. For this particular second last carbon atom, it has only satisfied 2 bonds. So it has the scope of forming 2 more bonds, right? So I will assign CH2. For the third last carbon atom, it has only 1 carbon or 1 bond satisfied. So I will assign 3 carbon atoms to this group. Okay, initially you'll be facing problems in writing this number of hydrogen and all, but once this you put into practice, it will be very easy. So the next is octane. Okay, it's a pretty simple one. There is no branching here. Octane, simply we have to name the alkane here. So we are having octane, means oct stands for 8 carbon atoms. So I will write 8 carbon atoms in a chain. Yeah, all my 8 carbon atoms are done. Now the easiest or the last thing is to assign the number of hydrogen atoms to them. So for this carbon atom, there are 3 other bonds left, and so is the case for the last carbon atom. Okay, but all the other carbon atoms, they are bonded with 2 or they are already 2 bonds down. So we simply have to give them or assign them 2 more bonds in the form of hydrogen. So CH2, CH2, CH2. Okay, we get octane here. Now this 2,5-dimethyl hexane. Okay, so first I have to see the word root, which is hex. That means a 6 carbon atom. Okay, now in the second and fifth position, I have the dimethyl group. So whether I can choose this as the second position, third, fourth, fifth, this as my fifth position. Here I will assign dimethyl, means 2 methyl groups are attached. Okay, so in the second carbon, there will be a 1 carbon branch, in the other there will be a 1 carbon branch. Now I have all the positions and all assigned. I will simply have to put the hydrogens according to the correct number. So if I see this carbon atom, it has only satisfied 1 bond. So here I will give 3 carbon atoms or 3 hydrogen atoms to this carbon. Similarly, the last carbon also has 1 bond down. So 3 hydrogen atoms here. Same is the case with this and this also. And rest all other carbon atoms are already 2 bonds down. So we have to give just 2 more hydrogen atoms to them. So CH2, CH2, CH2. Okay. So these were some questions on the other way, like we have the names here. From the names you have to derive or you have to come down to the structures. So we have done it both ways, right? So for now, I guess alkane, alkene, alkyne and the nomenclature of branch chain hydrocarbons might be clear with you. So that's all for this video. In the next video, we will be seeing some other topics of the chapter. Thank you so much.